Hello, everyone. You're on the Z conference in Blockchain Professionals Community booth. And I'm Alexandra Pitkevich. I'm leading blockchain practice at EPAM. And at the same time, I'm leading Blockchain Professionals Community. And today we are going to speak about reference architecture. But let's start from the beginning. While delivering a number of blockchain projects, we actually started to think about professionalizing our delivery. And we started to think how to make that more efficient. And during the thinking that, we were able to develop several assets which are helping us to professionalize the delivery. First of all, we started with the delivery methodology, explaining everybody around how blockchain projects needs to be delivered. And as any of our assets, it's not so much dictating what should you do, but that's more structurizing your way of thinking. That's showing you what you could do and what would be the results, and providing you enough help with in terms of the templates, materials, thirds, and structure also, and in some cases providing you with the tools. So, well, we do have 8 food delivery managers, as I said, delivery methodology. Uh, Still, because of the maturity of the technology, we do a lot of discovery and pre-discovery, basically explaining our clients what their use case should be and helping them to realize where the value of blockchain. And for that, we do have blockchain book of work. We also have portfolio of the use cases explaining our clients basically how giving them ideas, supporting their brainstorm of what are the common use cases in their industry. We do have building blocks to create Ethereum-based blockchain solutions on a robust way. That's like Lego. And we do have a lot of methodology and test tools set up and automated setup to deliver the quality assurance services. But today I'm going to speak about the reference architecture. And the reference architecture is a huge topic in itself. Actually, in this conference, we have two talks about the reference architecture today, and that's the first presentation. We are going to speak about requirements towards blockchain solution, about, when product owner think about the solution, what aspects it should cover, about what it should think. That's a great aid for a majority of the product owners. Technology is new and not everybody have experience of using the solutions or bringing life those solutions or building the solutions. So not everybody understands what actually needs to be defined. And a huge problem of any project where the product owner doesn't realize the all aspects of, for example, enterprise blockchain solution. And that's why we started our discussion today from these aspects of the reference architecture. On a second talk, we are going to discuss the components, like what we're going to discuss runtime and technical architecture for delivering blockchain, because that's important to see not only for the final solution, but also how you build this solution and what is the process around the solution built and what aspects needs to be covered during this process. But that basically gives you the basic modules, the basic, I would say, subjects about which you need to think. But staying focused today, we are going to discuss requirements today. And basically, we are speaking today about designing enterprise-grade solutions. And any enterprise blockchain network solution should facilitate the extension and optimization of the processes across organization boundaries. You like most likely you know that the great value is unlocked by the blockchain solutions where multiple organizations or multiple parties are involved in a solution. It gives you the great opportunities and great value, but it's also brings quite some of the challenges in defining the solution architecture. And the main goal of this presentation is not to dictate solution architects what to do, but structurize their thinking, highlight about what they need to think. And starting from a very, very top level, first of all, the architects needs to understand the infrastructure on which the solution will rely. It's basically how to build the underlying environments to facilitate our solution. Then architects start to think about the data, how to manage, secure, and analyze data kept on and off chain. What data keep on and off chain? Then security aspects of the solution, how to ensure that your solution protects the user system and data interacting with IT. Presentation layer, how to create appropriate UI capabilities for solution. Integration, how to integrate old, current, and new systems with distributed ledger technology. And there are a lot of aspects. There is like a functional aspect, what needs to be integrated. There's a technology aspects of how to do those integrations and what capabilities offered us by the external solutions and what capabilities are available in a solution we are deciding to use as a foundation there. DevOps part, how to unify software development and software operations for our solutions. Remember, in many cases, we're speaking about multiple organizations. So, look into what we actually need to define. We are starting from the core layers of the DLT platform, of core DLT functionality, core services, which are containing functional capabilities like smart contract, business logic, consensus mechanism. The distributed infrastructure, the distributed ledger and its services, they should rely on a certain infrastructure, on a physical hardware, IoT devices, virtual machines, clouds, mix of that. Then data capabilities. I've already was speaking about on and off chain data, how we store that, how we manage that. Yeah, all those aspects. Integration, presentation layer, security around this always needs to be secure, and DevOps. That was exactly what I was just speaking to you. And so what we must understand from this structure, well, basically the core services, they which we define, they use certain data, rely on a certain infrastructure, and then they call the certain integration services. The services may offer such capabilities as peer-to-peer networking for DLT nodes and can offer like online and like on ledger and off ledger data operational mechanisms. And all of this needs to be secure. And the data layer of our solution, it consists out of the transaction itself. It may contain references to the external entities, and additionally, it may contain the definitions to the blocks of the transactions. It's well known that many of blockchain technologies, they operate not only transaction paradigm, but also block of the transaction paradigms. DevOps here includes IDEs and capabilities to build and deploy smart contracts. Administration includes asset management for regulated or private DLTs and permission DLTs. So this is a top level of our reference architecture. And now we are moving towards the requirements topic. Basically, to be successful, any architect must understand both types of the requirements for the solution they are working on. They must think about the challenge if it's unrealistic or like, and they must to eliminate any costly decisions. So any solution has functional and non-functional requirements. And distributed ledger provides a certain structure or like certain need to define uh, certain type of the requirements. Like for example, when we're speaking about the functional requirements, the array of them is covering transaction processing, and that speaks about the ability to support different transaction processing patterns. That's the topic where our product owners must think and must define. Consensus, the possibility of securely agreeing on a state of the distributed environment. It's a part of like the transaction processing. While we are processing the transactions, like the nodes or the selected set of the nodes or dedicated notaries are deciding if transaction happen or not and to what degree does it happen. This all needs to be defined. And the smart contracts, the business logic and how this business logic also stored on chain and how does it evolve. Tokenization aspects, the ability to represent any digital or physical asset as a token. Also, if that's in the scope of our solution, it should be defined by the product owners. Chaining, how transactions are shaping the chain. That's not a surprise that, yeah, we are calling blockchain, but it's not necessarily that any foundation technology supports this as a literal chain. In some cases, it's a tree. In some cases, there are like different structures of connecting transactions one to another. And that's the important requirement. And very good when our product owners understand that from the very beginning what they actually want. But that's normally requires a mature product ownership. In some cases, it can be decided together with the technology team because while the architects normally can explain the aspects of those decisions, the consequences. But anyway, the requirement should come from the product owner. Network incentivization, very, very important aspect of the requirements. Very frequently, it's not taken care well. Basically, we do have network independently if it's like a private network or if it's a public network. With public network, that's probably the key aspects of the solution. But for any type of the network, you must understand and you must define why the participants of your network would behave properly, would behave how that's expected from them. What incentivization mechanisms are laying, like supporting this good behavior. And the good behaviors means that they're not lying. Then they're not bringing themselves down unexpectedly. Then it's they're processing the transactions according to mutual agreements that they're participating in the consensus. Next, confidentiality aspects, ability to limit code and data visibility and actioning. Like it can be like it's privacy and permissioning. And that's again another very important aspect of a solution, especially on enterprise layer. When we're speaking about enterprise grade solutions, like the areas of what who can see, what who can do is very, very important. And that should be defined as a requirement to the solution. Transaction accessibility, support of the different transaction accessibility patterns. Another aspect which a lot of like new product owners, they just don't think about that. And that's why we are bringing this framework. So to structurized thinking, say, guys, you need to know how is it going to work. Are you going to support different types? What types would it be? What support would you like to see? And the same for lightweight node. Like you can have different types of the nodes in your network. and what those different types would be, what they should be able to do, what functionality they will provide, what data would be accessible for them, what motivational aspects would be behind that. And this all is a functional side of our application. And that's, well, unfortunately, that's not it. It looks like a lot, and that's indeed a lot, and that shapes what your solution is. That tells your team, that tells your users also what it's going to be. Take your stakeholders, that outlines what you're going to build. And then, and that speaks of what. And now we are coming to the non-functional requirements. And non-functional requirements define how those functional requirements needs to be achieved. It speaks about the how aspects of the solution. And here we have even more and even like more requirements towards how of the blockchain solution. And where the top level is obvious, the top level is coming from like TOGAF. And most of you, like most of the architects, should know what it needs to be. What we are going to see now is speaking about applicability of this non-functional requirements model to DLC network, what we are going to define. Compatibility, let's start with that. That's the ability of the solution to exchange data and integrate with other system components. And here we are speaking about data exchange, integration, and federation. Then performance. That's the ability of the solution to perform a high amount of functional workload. Like, well, this one is luckily well discussed for the blockchain solutions. But here we are speaking about monitoring, about latency, and about throughput. And the majority speaks a lot about throughput, and the aspects, for example, of the performance monitoring is totally lost. Reusability. The ability of the solution to fit in the current IT development capability, reuse knowledge and components existing with the organization in order to minimize the development footprint. Very frequently, those requirements are coming from the client enterprise architects. They're looking at your solution and say, by the way, we have this, and this already in the network. Please use our architecture models. Please use our data models and the canonicals. And those components already exist. Why do you need to build that separately? And all those decisions needs to be taken consciously. And here we're speaking about a modular design, about decoupling and configurability. In some cases, we can look to the life of our, like a future life of our solution, to our roadmap, and also define how the solution is going to be, like how the evolution is going to be, and what parts of the solution we should be able to reuse for any other future solutions. But again, that's normally work together with the enterprise architect of the organization. Another important topic, scalability. And that's the ability of the solution to handle a growing amount of work, of its potential to enlarge and to accommodate to this growth. For example, EPAM participated in Sigma Ledger solutions. We are developed that in a partnership with a Sigma Ledger. And initially it was sizable Ethereum-based private permission network. And recently, it needed to be rolled out its Cube solution, its functionality to support coupon processing for hundreds of point of sales. And if the solution wouldn't be designed well from the beginning, we wouldn't be able to support that. Important topic. And probably you are not going to achieve all of this, but at least you need to outline what it can be and to build the possibilities to extend the solution, and not to build like any ill-designed patterns which will prevent you from achieving the future scalability. And here we are speaking about the scaling and packaging. Then deliverability aspect. And here we must admit that very few organizations are thinking about this. That's the ability of the solution to be designed, developed, deployed, and maintained quickly and efficiently. That's the most problem we meet in any delivery. Absence of thinking about that, absence of how the heck it can be deployed well, how it can be developed efficiently. Surprisingly, you can think about that on the design stage. You need to think about that if you want to save time and money. And here we're speaking about the deployment, about the collaboration, automation, and environments. And there can be a lot of wisdom used. And obviously, the more organization does that, like what the better it knows that, the better, like the more learning is incorporated, the wisdom of how we did that and where there were mistakes and how we proceed through that, and the lessons learned are important here. But at least at the beginning, think about the efficiency of your delivery at the design stage, how you would deliver that in parallel, how you can cut it to the pieces, and how you can test in parallel with the delivery, how your infrastructure has to support that. This all is affecting the resulting cost of the solution. And obviously, all our clients want the solutions to be good quality and delivered cheaper. Then another aspect, recoverability and availability. Those we think usually. Those architects used to think, because those non-technical requirements are normally in corporate framework. They're normally dictated by the enterprise architecture frameworks of our clients. That's the ability of the solution to retrieve lost, corrupted, damaged data and obtain any information with the system. Here we're speaking about the data recovery, fault tolerance, and operations. DLT solutions, they have specific, and you have to think about the network and the data recovery in terms of the network. What obviously the architecture, like the basic DLT architecture, helps with the fault tolerance, but the data recovery and operational challenges are in, and architects needs to take care of that seriously. Traceability and auditability, favorite topic for the DLT applications. That's where our life is kind of easy, because the technology itself helps us. The technology itself provides us the mechanisms which we can just use, and they would be used anyway, and we are benefiting from that. That's basically the ability of the solution to maintain and ensure the accuracy and consistency of data and the processes of the entire life cycle, while examining the management controls and event logs within the infrastructure. As I already said, DLT technology provides a lot here, but at the same time, it has to be controlled and manageable. And we have to have those controls. And here we're speaking about the auditability, immutability, and propagation. And those aspects needs to be defined. Those are the parts of the non-functional requirements of the solution. Last but not least, security. Security, and that's the ability of the solution to secure data access to the specific set of the users or system components. And here we are speaking about the access control, privacy, and the threat management. And those needs to be defined. And well, we've covered functional aspects of the requirements and non-functional aspects of the requirements towards a DLT solution. We try to provide the aid for the product owners and also for the delivery leads and for the tech leads and the teams, because when the certain aspects are not defined, that means that you will hit those gaps later on while you're delivering the solution. You will hit that in a form of the questions for the delivery team. How should it be? In some cases, you can hit that from the QA team or from the operational team if you overlook those requirements for a long time. Means that, well, you didn't think about that. And then when you are trying to test or bring life the solution, yeah, you are confronted with those topics and saying, what about monitoring, for example? What about the scalability? Again, those topics are like more, for example, when we are speaking about the deliverability, you obviously eat the problems while you're delivering. When we are speaking about recoverability, availability, all this stuff, you hit the problems during the operations. Compatibility topic can come at the end as a surprise. The same for scalability, for reusability. You must not underestimate the importance of that. And that's, again, that's the first speech about blockchain reference architecture. That's a top level. We're speaking about the requirements towards a blockchain solution. And in the course of this conference, we are going to have the second talk where we are explaining the approach towards delivering the components of the DLT solution. And we are exploring the way of the architecture thinking, which is aligned with those requirements. That this reference architecture structure is basically telling us what our solution should be compatible to, like should be able to do in every aspect of its working. And that would be our second speech. Please join us. And that was Alexander Pitkevich. Thank you. Thank you for your time. Come to our second talk. Bye.